So in this video, we'll be discussing the October-November 2024 paper, Pure Mathematics 1-3. Let's have a look for question number 1. There's an arithmetic progression with the 4th term 15 and also the 8th term 25. So find the 30th term of the progression. Right, so the keyword for this question basically is the arithmetic. Right, so arithmetic progression. So you know that for arithmetic progression, basically the formula that involved in the number of term, which is 4th term and also the 8th term, the n term, I would say. The general formula for n term will be basically Tn equals to a plus n minus 1d. Where d is the common difference, a is the first term, right? And now since we are given two information here, 4th term is 15. Okay, so that means I'm having T4 equals to 15. So what is the T4 here? N equals to 4. A, I don't know what's the value, so I put it as a A. N minus 1, you get a 3. So you're having 3D equals to 15. This is my first equation that I get from the first information here. And the second information I get is 8 term. So for 8 term, I'm having T8 equals to 25. It will be equals to A plus N minus 1, which is 8 minus 1 becomes 7. So 7D equals to 25. Right, so before I can proceed to get the 30th term, I need to know what is the value for A, and also I need to know what is the value for D first. So what I did here is I tried to solve this equation simultaneously, or you can directly take equation number 2 minus equation number 1. So when you take equation number 2 minus equation number 1 means A minus A. You get 0. 7D minus 3D, you'll be having 4D. Equals to, for right hand side 25, you minus 15, you are having 10. And therefore, your D is equals to 2.5. When your D equals to 2.5, substitute back into either the first or the second equation to get the A. Alright, so by right, you'll be having A. If I use the first equation, I'm having 15 minus 3D. And my A here will be equals to 7.5. Okay, then now, since I already know the value for D, I know the value for A, and I can proceed to find out the 30th term, so T30. So in this question, they're asking for 30th term, right? So what is the value for T30? Formula again, A plus N minus 1D. So A plus N is 30, minus 1 become 29, and D is 2.5. Okay, so from here, if you didn't do any careless mistake when pressing calculator, by right, your answer should be 80. Right, yeah, so this is how we solve question number. Alright, so let's have a look for question number 2. They want us to find the exact solution for the equation of this one. So I highlight the keyword exact solution. The keyword exact means that your answer must be insert form, pi form, or maybe a fraction. Okay, it cannot be a long decimal number later, right? So the exact value or exact solution means that it must be in insert form, pi form, or whatever. Okay, cannot be long decimal number. So for this particular equation, if we have a look here, we will know what is the value for cos pi over 6. Okay, then we need to keep the tangent 2x and solve for the value of the x. Alright, so what's the value for cos pi over 6? Of course, you can press calculator, or you can use a triangle to help you. Okay, so for the basic triangle here, when I'm having 60 degree, which is pi over, 30 degree, which is pi over 6, yeah? Sine 30 is half, right? So 1, 2, and this is square root 3. Right, so pi over 6 is 30 degree. So when I'm looking for the cos pi over 6 from the triangle here, you can see that it is actually adjacent square root 3 over the hypotenuse 2. So cos pi over 6 is square root 3 over 2. So this is the exact form. If you're using MS calculator, your calculator basically cannot give you an exact solution. So you have to use a triangle to help you, right? Okay, so tangent 2x, I don't know what is it, so you just copy it. Then plus sec 3 over 2 equals to 0. When you're having sec 3 over 2 and sec 3 over 2, right, that means you're having half sec 3 plus another half sec 3. So eventually you're having a sec 3. So sub3 plus tangent 2x equals to 0. Okay, so to solve for the x, you need to bring all the number to the other side. So you bring it over, become negative sub3. Okay, all right, then now I want to know what is the basic angle. Okay, what's the basic angle for this tangent 2x negative sub3? So to get the basic angle, usually what I do is like I'm trying to ignore the negative in the value first. So I'm taking the basic angle for tangent inverse sub3. Okay, so ignore the negative sign, because the negative sign here later I will use it to see which quadrant I need to consider to get my final answer, right? But to get a basic angle, it is always from the first quadrant. It must be always an acute angle. Therefore, I will just every time I will just ignore the negative sign. So tangent sub3, if you press calculator by using maybe ES or ES plus calculator, then you'll get the answer in exact solution. But if you are using MS calculator, then you have to use back this triangle again to help you. Alright, so how can I get tangent inverse sub3? So from the triangle here, you can see that if I'm having tangent pi over 3, it is equals to sub3 over 1. Opposite over adjacent, right? So if tangent pi over 3, it is equals to sub3 over 1. Therefore, your pi over 3 will be equals to tangent inverse of 3. So I'm using the calculator, I'm using the triangle to help me. If let's say you're using the MS calculator, right? So from here I know that my basic angle is pi over 3. Okay, but this is not the final answer yet because it is just a basic angle for me to refer and get my final answer. Alright, so let us investigate further and see which quadrant of the answer I need to accept it. Alright, so you can see that there's a 2x here. There's a 2x here. And in the question, the range given for the x is from negative pi over 4 to pi over 4. When I want to go through all the quadrant and figure out which quadrant of answer I need to know how many quadrant I need to go through first. So what I need to do is like, usually I will change this one become 2x. So pi over 4 times 2, you'll be having pi over 2. Then this one also the same thing, you're having negative pi over 2. Okay, so that means later when you want to locate the answer from different quadrant, you need to consider these two quadrants here. 0 to pi over 2 means this quadrant. Okay, then 0 to negative pi over 2 means this quadrant. So you need to get answer from these two quadrants basically. And these two, third and fourth, second and third quadrant, no need to consider it at all, right? Okay, and now let's consider our equation again. I'm having tangent with a negative value. So in which quadrant tangent is having a negative value? So in first quadrant, tangent is always positive. So I don't want to accept the answer from here. And therefore, I want to accept the answer from this part. So to get the answer from this part, basically it should be a negative basic angle. The data here means basic angle. So if I want to accept the answer from this part, it should be negative basic angle. So my 2x basically will be equals to negative pi over 3. Because when you take the tangent over, become tangent inverse, right? Okay, so you can see that 2x, you should have the 2x when you bring the tangent over. So therefore, 2x is equals to the negative basic angle. And to get the value of x, you need to divide your answer by 2. So you're having negative pi over 6. Okay, so this is how we solve. Alright, so we are now at question number 3. They are asking for the coefficient of x power 3 and also x power 4 for this particular bracket with power 5, where a is a constant. Give your answers in terms of a. Right, so basically this question belongs to binomial expansion. Alright, so what's a general formula for a binomial expansion here? If let's say I'm having a plus b power n, then the general formula for every term will be NCR, a power n minus r, and also b power r. Okay, so this is a general formula for every single term in the binomial expansion here. Okay, and now if I want to get a x power 3 term for this particular bracket, I need to do a little bit of analysis before I can decide the value, okay, of the R. So I'm having NCR. A is a 3, B is negative AX. I need to decide what's the power that I need to put for the X and also the 3. Since the question is requesting for X power 3, right? Therefore, the power with the term with the X, I need to put it as a 3. If this is power 3, then of course the R will be the 3 as well. And what happened to the power of the 3 here? For this number 3 here, it will be a 2. So that 2 power 2 plus the power of 3 equals to power 5. Okay? And now press the calculator and help you a little bit. So by right, you'll be having this as negative 90, then a power 3, x power 3. Yeah? And how about x power 4? Okay, so if I'm looking for x power 4, the same thing happen here. You need to write out the particular term first, but I don't know what is the power yet. Since they're asking for x power 4, right? So I need to have a power 4 here at the term with the x. So this will be power 1. So that 1 plus 4 equals to 5. And this is power 4 as well. The number R here is a 4 as well. So again, by pressing calculator on this particular term, you'll be having 15. A power 4, x power 4. Okay, and since the question is asking for coefficient of x power 3, coefficient means that the number in front of the x power 3. So this whole term is a whole term with x power 3, but if I want to mention or I want to provide the value for the coefficient, we should only consider the number or the constant in front, which is negative 90 a power 3. And the same thing happen if we are looking for the coefficient of x power 4. Then what should you have? You should have 15a power 4, right? Okay, so please take note on this, yeah, because they're asking for coefficient. So you shouldn't include the whole term. You should basically write out the constant in front of the x power 3 or x power 4. Alright, so this is the coefficient that they want. Okay, this is what we have. Then let's proceed to part 2. Okay, so for part 2, they are saying, given that the coefficient x power 4 in this expansion is 240, find the positive value of a. Okay, so before that, maybe you can try to compare what we have. At first, please have a look for this particular term. 3 minus ax power 5 is what we have in the first part. 3 minus ax power 5. That also actually hint us that very likely we need to use these two answers from the first part and apply in the second part. Okay, because they are linked. This bracket and the part A answer, part A bracket is the same. Okay, alright, so let's have a look for this second part here. I'm having ax plus 7. Then I'm having negative 3 minus ax power 5. Okay, so they are interested in the coefficient of x power 4 for this question. X power 4. Alright, so if you try to observe, ax plus 7 is a power 1. This bracket is with power 1. I cannot expand or I cannot do anything, so I just keep it in the bracket form first. Then for this particular bracket, you need to maybe analyze a bit also that before you can decide the answer. Ax, I have to multiply something here to get x power 4. So the something here is actually this particular term. Okay, the x power 3 term in the previous question. Alright, then for the 7, if I want to get x power 4, I need to have something with x power 4, which is this particular term with x power 4, okay, from the previous question as well. So which means I can directly substitute my answer in the first part in this bracket. So I'm having negative 90 a power 3 x power 3, then plus 15 a power 4 x power 4. Yeah, and now you can start simplifying your answer, where you take ax, multiply with this particular term, so that eventually you'll get a term with x power 4. So if you try to expand it, you'll be having negative 90 a power 4 then x power 4 for this black color arrow. And now for the term 7, you multiply with the x power 4 term, and you should get 7 times 15, which is 105, a power 4, and also x power 4. Okay, so both are the x power 4 term. You can also further simplify them. You take negative 90 plus 105. Okay, because you're having a power 4, x power 4, they are actually the same term. So you can combine them together. So negative 90 plus 105, you should have 15. A power 4 and x power 4. And what did they say? They say that, oh, the coefficient for x power 4 for this particular expansion is 240, which means that you can compare the value with the coefficient you get. So the coefficient for x power 4 is this one, 15a power 4. So you let 15a power 4 equals to the value 240. So from here, slowly you'll get the answer. So 240 divided by 15, and you have to simplify them. Then after that, you have to take the fourth root, okay, of the a, or you can press square root for 2 times. When you are pressing the square root for 2 times, or when you take the root of fourth, right, by right you should consider plus and minus sign. Okay, for square, then fourth root, okay, you have to basically consider the plus and minus sign. And by right you have a value, 2 value for the a, where it should be 1 positive and also 1 negative. Okay, but of course, if you try to read the question one more time carefully, you can see that they want you to find the positive value of a. So of course, I cannot accept both answers here. So what I need to do is that I have to emphasize again, my a is equals to only a positive value 2. Alright, yeah, so this is how we solve question. Alright, so question number 4. They want us to solve this equation, and the data is between the 0 to 360. Right. For this question, right, if let's say you can observe the pattern, you're having a power 4 here, then the second term is power 2, where the power 4 is the double of 2, right? So it belongs to the quadratic form equation, yeah? I don't know whether you can observe it or not, where you can see that it is actually 4x squared plus 12x minus 7 equals to 0. Okay, so it is basically a quadratic form equation. If you can't see it, then you can just let your x equals to sine square x. So you can see it in a clearer way, sine square theta. Then you can see that it become a 4x squared plus 12x minus 7. Alright, so for me, to solve this kind of equation, basically I have to use the quadratic method. Right, okay, so now let's solve it. 4 sine square plus 12 sine square, 4 sine power 4, sorry, plus 12 sine square minus 7 equals to 0. Usually we'll try and see whether you can factorize them or not. Alright, so 4 and 7, right? Maybe we can have factorize them in this way, where we should have 2 sine square theta and also 2 sine square theta. And then I should have a 7 here with a 1. Then I want to have positive 12, so I can have plus 7 minus 1. So I'm having 14 minus 2, which is a 12. Okay, then I let it equals to 0. Yeah, so I'm trying to factorize them by using the quadratic method. And after that, I need to solve the equation. So I'm having sine square theta equals to 1 over 2. And also sine square theta equals to negative 7 over 2. Okay, and for this part, sine square theta equals to negative 7 over 2. When you want to get the basic angle, if you try to press sine inverse 7 over 2, you'll get a math error, because this value already more than 1, or maybe already less than negative 1. So it is already out of the range for any the sine function. And another thing that you need to know, that for sine square theta, right, the range should be from 0 until 1 only. So this one definitely is out of the range. Therefore, you won't be able to get any solution from this part. Right? And now I need to get the answer from this part. Before I can solve them, what I need to do is that I have to take square root first. So when I take square root, I need to consider the plus and minus sign. So I'm having 1 over 2 when I want to take square root. Okay, then I want to get the basic angle for this question. So how to get the basic angle for this question? I need to have sine inverse. So like what I told you in the previous question, I always ignore the negative sign. I only consider the positive side. So what is the value for sine inverse 1 over sec 2? So you can directly press calculator for your answer in this question. So because it's in degree, so it's easier for you to get the answer directly. So sine inverse 1 over sec 2. By right, you will get the basic angle 45. Okay, so this is the basic angle 45. And when they are looking for the final answer from 0 until 360, right, you have to go through the quadrant and see which answer from which quadrant you need to accept. Okay, so 0 to 360 means all the 4 quadrants here. For all the 4 quadrants here, right, in the first quadrant, everything is positive, and the answer is the basic angle. Second quadrant, sine is positive. The answer is 180 minus the basic angle. Third quadrant, tangent is positive. Answer is 180 plus basic angle. Then the last quadrant is cos. Answer is 360 minus basic angle. So let's come back to our equation here. I'm looking for sine, either plus or minus. Okay, so to get the answer for theta, what I need to do is I have to go through the quadrant. I start with first quadrant first. Okay, so sine is positive, and I want to accept the answer from this part. So theta means the basic angle 45 is the answer that I want to accept. For second quadrant, sine is positive. My equation, I also consider sine positive, right? So I want to get the answer from this quadrant as well. So I'm taking 180 minus the 45. So you get 135. For third quadrant, also the same, 180 plus theta. Third quadrant, only tangent is positive, but according to the equation, I also want to accept the answer for sine negative. So I also want to accept the answer from this quadrant. So get the answer is 180 plus the basic angle. So you take 180 plus for basic angle 45. So you'll be having 225. Okay, and the last one for the cos, 360 minus the basic angle. Right. Then again, for this quadrant, cos is positive. But according to the equation, I also want to accept sine negative answer. So I still accept the answer from this quadrant. So 360 minus the basic angle, and you'll get 315. So we should stop here for getting the answer in theta, because they are asking us for 360. That means we need to go through only one round or one cycle. Alright, and basically this 4 will be the answer for this question. Right, so this is how we answer question number. Okay, so question number 5. We are given a diagram, and then the equation y equals to fx is a solid line. So this is my function fx, and then I'm having gx in the broken lines. So they want us to describe fully a sequence of 3 transformations. So I had the keyword 3, which transform the graph fx to gx. Okay, so we have to do it very slowly here. Since they're having 3 transformations, yeah. Right, so let's have a look and see what kind of transformation is involved here. All right, so we are having a diagram, so it's much more easier for us to visualize it. Right, so we are having the original graph like that, and the graph under transformation is something like this. So you have to think what kind of transformation is involved. All right, so basically you can see that the tail here, this one I call it as a tail, right? Where if you try to compare it with the graph after the transformation, right, the tail become this part. Okay, because it is like longer, right? 2 unit. So this one is 2 unit reflect. So it become the other side. So basically the reflection is involved. So that means the very first transformation involved, I guess, is something like this. So if I reflect it through the y-axis, okay, then my graph will be something like this. Okay, so this is how we change the direction of the graph, right? Because originally the tail is this side, and now it become this side. So in reflection in the y-axis is involved. Okay, so maybe I draw it nicer first, yeah. Okay, so the first one, I will say that it is a reflection in y-axis. Reflection in y-axis belongs to the x direction transformation, yeah, because you are reflecting it left right. So left right means in x-axis, sorry, in x direction, but it is the y-axis is the mirror. Okay, so after I carry out the first transformation, I realized that the height of the graph, because if you have a look for the original height, this original height here is 2 unit, but now the height for this part already become 4 units. So there's a stretching in the vertical direction, okay, from 2 unit to 4 unit. Then same thing happened here. If let's say you have a look for this one, this is 1 unit, right? And then after reflection, after the transformation, this is 2 unit. So basically you can see there's a stretching in the y direction from 2 to 4 and also from 1 to 2. So the second reflection that we have, the second transformation that we have is actually a stretch in y. And then what's the stretch factor? The stretch factor should be 2. Okay, so if I try to draw the diagram, alright, so you can actually use the point to draw the diagram. This is the original point, which is 0, 3. Then for the y value, you have to multiply with 2. Stretch factor is a 2, right? So if you take 3 times 2, then you get a 6. So after the transformation, this particular point will become 6. Okay, then same thing happened here. For this particular point here, the original coordinate is -1 and 1. And then for the y coordinate 1, you have to multiply with 2 after the stretching. So when you multiply with 2, it will become -1 and 2. So where's the -1 and 2? -1 and 2 will be this point. This is the -1 and 2, right? Okay. Then after that, same thing happened here. This is -1 and 1. After the transformation, it will become -1 and 2. Okay, then let us have a look for this particular point here, the end point here. For this end point, the original coordinate is -4 and also a 2. Then for this y coordinate, if you want to have a stretch in y, you have to take the 2, multiply with the factor 2 lah. So 2 times 2, you get a 4. So -4, 2 will become -4 and 4. Where is -4 and 4? Here. I put it as blue color lah. Okay, so the second transformation is a stretch in y factor in the y direction with the factor 2, right? So if you already go through the second transformation, which is the stretch in y direction, your graph will look something like this now. The blue color one. Okay, so the red color one is the very first reflection. Okay, left right reflection. After that, you have a stretch in the y direction, so it becomes something like this, and you realize that it is still not the image of the last step yet, the last graph yet, the broken line graph. Okay, so how can I make the blue color graph into the broken line graph? So I think it is quite obvious, because you can see that you are trying to move this blue color point 1 unit to the left, and you get this one. Then if you try to compare every part, also the same. For this point, if you move it to the left, you have this. And this point, if you move it to the left, you have this. Then this point, this one, if you move it to the left, you will be having this one. So very obvious that it is a shifting, all right, translation. So for the third one, you should be having translation to the left, right? So you're having in x direction, or you can just write as write out with the factor -1 and 0. -1 is because of you going to the left. All right, yeah. So basically, these are the 3 transformation involved in this particular fx to gx graph. All right. So for the answer here, first you must write out reflection through x-axis or y-axis. That's a keyword that you need to show. Then for the second transformation, you have to show the keyword stretch in the direction and what's the factor. Then the third one is translation, and then what's the factor here. Alright, so all this must be shown in your exam, and basically it will provide you with the marks. right? Okay, so this is what we have for part A. There are three transformations involved, right? So these are the three transformations that we have. So let's have a look for part B. They are asking for find an expression for gx in this form: a f bx plus c, where a, b, c are integers. Right, so we are going to get the pattern of a, b, and c here into the function form. So let's have a look for our answer again. Okay, so first of all, right, before we can write out the equation, we need to know what kind of transformation do we have. So when we are having reflection in the y-axis, it is a transformation in x direction. Transformation in x direction. Okay, and then for the stretch in y, it is a transformation, okay, in y direction. And then for this one, translation with the vector -1, 0. The -1 is the x, right? So this is another transformation in x direction. Okay, if let's say your transformation is purely 1x and 1y, right? The sequence doesn't matter. All right, then let's have a look for our answer here. We are having two transformation in the x direction, this one. Okay, therefore, when you want to write out the equation, you need to be very, very careful. Okay, all right. So for the transformation in x direction, now let's have a comparison. If I write my transformation, this one, f(a)x plus b, then basically this one means that translation first, translation in x first, followed by stretch. So that means the first one is a translation. You move the b over, right, become -b. So you're having a translation with the vector or with the factor -b. Then only you multiply the a, stretch. This is for x-axis now, all right? And if you have a look for our question here, we are having transformation first. We are having the reflection first. Reflection, which means that it is a type of stretching, right? So we are having the stretching first, then only followed by translation in the x direction. So you want to write out this kind of equation, right, where reflection comes first, followed by translation one. The general formula should be this one, f, and then you're having a, then a plus x plus b. So when you're having this one, then it means that you should have a stretching first, then followed by translation. Because when you're looking at this particular bracket, right, a bracket x plus b, you bring the a over first. When you bring the a over first, it means it is a stretch. Then only you bring the b over, become -b, then it is a translation. Right? So please take note about the difference between these two. Okay, so in our sequence here, reflection come first. Reflection means stretch, stretch in the x direction come first, followed by translation. So when I want to write out my function, it should be f. So stretch come first, a. What is the stretching factor for the reflection? So reflection means you have to put a negative. Okay, then x. For our -1, I'm moving it to the left hand side. 1 you need to the left hand side, right? If you want to put it inside the function, -1 you bring it to the left hand side, it will become +1. So you're having +1. Okay, so this is how I write out my equation here for the function for these two transformation in the x direction. So the negative should be outside the bracket of x plus 1. Okay, so I just want to emphasize on the difference for these two. Okay, then after that, what happened to the stretch in the y factor? Maybe I put it nicer, right? Reflection is red color, so I put it as red color, negative. The translation is -1 become +1, so +1. Okay, then after that, what happened to the stretch? So when you have any stretching or what, you have to multiply a number outside the basic function, so you just multiply the constant term outside the basic function. So our stretch factor is a 2. Therefore, I have a 2 outside here. Okay, all right. And after that, I need to further simplify this one, because for question number 2, they are asking us to put it in this form, bx plus c. Okay, but our pattern here is not bx plus c yet, because we're having a negative outside the bracket x plus 1. Therefore, we should further simplify them, where I will multiply the negative inside the bracket. It will become negative x minus 1. Okay, so this is the final answer that I want, where the A is 2, B is negative 1, C is negative 1. Alright, so this is basically how we get the answer for part 2. Alright, so it is a little bit confusing for some of the students. Maybe they are not aware the difference between this pattern and also this pattern. Alright, so please make sure that you take note that for these two way of writing out the function, right, the sequence of the transformation is different. Okay, yeah, so this is how we solve question. Alright, so we are now at question number 6. Okay, so the first term of a convergent geometric progression is 10. Right, so they give us a few important information here in the first sentence. What is the meaning of geometric progression? That means you have the common ratio, right? So every single number multiply a common ratio to get the next number. Okay, so they said first term is a 10. So I know that the A is a 10 here for this case. And what's the meaning of this convergent geometric progression? So you see the keyword convergent, basically it tells you that the R is between -1 to +1. That means the modulus R is smaller than 1. Okay, so this kind of geometric progression we call it as convergent progression. And after that, when you are having a convergent geometric progression, then you will be able to get the sum to infinity. Okay, because if you're having a diverged geometric progression, then when you try to calculate the sum to infinity, basically you get infinity, right? But when it is a convergent geometric progression, the number becomes smaller and smaller from first term until the future term. Then eventually you'll get the sum to infinity, that it will approach to 1 value. All right, so that's the meaning for convergent. So they said that the sum of the first 4 terms of the progression is p, and the sum of the first 8 terms of the progression is q. Given that q divided by p equals to this value, so find the 2 possible values of the sum to infinity. So you can see that they want us to find the sum to infinity. That's why they emphasize this is a convergent geometric progression. Okay. All right. So maybe we have to go through a little bit about the sum of the first n term in the geometric progression. So what's the general formula for sum of the first n term in the geometric progression? You can refer to the formula booklet provided. So there are 2 basically. So one of them is a, then 1 minus r power n divided by 1 minus r. Okay, or another formula is, which is also the same, r power n minus 1 divided by r minus 1. So no matter which one are you using, right, basically both of them will give you the same answer, right? Okay, so let us try to set up the question here. Okay, q divided by p equals to 17 over 16. So this is the information provided. So q divided by p equals to 17 over 16. Since we know that q is the sum of the first 8 terms, so I want to put my all the information that I know into the formula here. Sum of the first 8 term is S8. So I will substitute A equals to 10. Then R I don't know. N is 8 because first 8 terms are right. So S8 means that N is equals to 8. So the Q here, I will replace it by using the formula. A is 10. Then I'm having R. Okay, sorry. Maybe I put it larger. Okay, so I will be having this. A is 10. Then r power n, r I don't know, n is 8, then minus 1, divided by r minus 1. This is the q, or sum of the first 8 terms, divided by the p. So p is the sum of the first 4 terms, right? So when you have a fraction, divided another fraction, which is S4, because S4 is also another fraction like this, right? So basically it will become a multiplication and you swap, you make the fraction upside down, right? So remember, so now I want to multiply with S4 but upside down one. So what's the S4 here? So A is still a 10, then R power 4 minus 1. Okay, then on top you're having R minus 1. So basically this is S8 divided by S4. But the S4, because it's a fraction, so fraction divided by fraction, I make it become multiplication. Then I make the denominator and numerator upside down. Okay, and after that it is equals to 17 over 16. Okay, then now you can slowly simplify all this. R minus 1 can be simplified with R minus 1. 10 can be simplified with 10. So I'm still having R power 8 minus 1 and also R power 4 minus 1. Okay, then maybe for this one, I want you to use, I can actually factorize this particular phrase. Okay, so what can I do is like, we can actually try to imagine x squared minus y squared. This pattern, R power 8 minus 1, right? It is very similar to x squared minus y squared. When you're having x squared minus y squared, you can further factorize become x minus y and also x plus y. Okay, and I want to apply this on this particular phrase here, R power 8 minus 1. Therefore, R power 8 minus 1 can be written as R power 4 with a square minus 1 with a square. So from here, you can see that your x square, right? The x is basically R power 4. Okay, then the y basically is 1. So if I want to further factorize this one, I will be having x, this is the x, R power 4 minus y, which is a 1. Then R power 4 plus 1. Okay, so I will substitute R power 8 minus 1 into this factorized form. Alright, okay, so let's continue from here. I'm having R power 4 minus 1, then R power 4 plus 1 divided by R power 4 minus 1 again. Then it is equals to 17 over 16. Okay, then now try to observe our equation again. Then you can further simplify your equation one more time. And eventually what do you have here is you are having R power 4 equals to 17 divided by 16 minus 1. And your R power 4 should be equals to 1 over 16. And you want to take the fourth root. So when you want to take the fourth root, right, that means square root for twice. Right, so you have to consider the plus and minus sign for 1 over square root 16. And by right, you should have R equals to plus minus 1 over 2. Okay, so this is basically your common ratio. You have two values for common ratio. One is positive half, another one is negative half. Okay, and now they want us to find the two possible values of the sum to infinity. Okay, before we can find out the sum to infinity, we have to ensure that our R is between -1 until +1 so that it is a convergent geometric progression. Then only you will have the sum to infinity. Okay, right. So if you have a look for our answer here, R basically both R plus and minus 1 over 2 lies between the range which is from -1 and 1. So that means this is a convergent geometric progression for both values of R. Alright, so I will have two values of sum to infinity. Okay, so let's continue from here. What is the formula of sum to infinity? So the formula of sum to infinity basically is A divided by 1 minus R. It is provided also in the formula booklet. In case you can't remember, you can still refer to the formula booklet. Right? Okay, and now we will want to substitute all the value inside and get the answer. Okay, so I will use the first R first. So when R is equals to half, what is the sum to infinity? So sum to infinity will be equals to 10 minus 1 minus half. So from here, you should get a 20. Alright, and how about if let's say your R is equals to negative half? So when your r is equals to negative half, so we apply it into the same formula here. Sum to infinity will be equals to 10 divided by 1 minus negative half. And by right, you should be having 10 divided by 3 over 2. And simplify it, you will get 20 over 3. Alright, so basically this is how we solve this question number 6. Alright, so let's have a look for question number 7. Okay, we are given a diagram, then they show us some details here. So it is a metal plate A, B, C, D, E, F, consisting of 5 parts. So their B, C, D, and D, E, F are semicircles. So these two are semicircles. Then the part B, A, F, O. So B, A, F, O, this one is a sector of a circle with a center O and radius 20. And D lies on the circle. So D, where's the D? Okay, so D basically is part of this circle, right? It is a point on the circumference of the circle. And then after that, they say the part OBD and also ODF, OBD and ODF are triangles. So the angle BOD and DOF are both theta radian. So these are the details, right, about the diagram. Okay, so now they tell us that given that theta is 1.2, find the area of the metal plate. Give your answer correct to 3 significant figures. Okay, so they're asking for area. Final answer is 3 significant figure. Okay, since they already give us the value of theta, then it'll be easy for us to calculate the area of the metal. All right. Okay, so let's have a look first. What do we need, okay, to set up the question? All right, so to find out the area, right, the area of the metal, I need to find the area of this big sector first. It should be no problem because to find out this particular sector here, basically it is half r square theta, right? So half, you have half, then r square means 20 square. And what's the theta, the angle here? So for this particular angle, you are taking 2 pi minus 2.4 because the theta is given 1.2. Okay, so I hope that this one should be no problem, yeah? So this area should be no problem for the sector. Okay, then let's have a look for the 2 triangle here. So for the triangle, okay, so for the triangle, basically I can find out the area by using this one, half AB, then sine theta. Okay, so I'm having half AB, which is 20 times 20, also 20 square. Okay, 20, this one, times 20, also this one, then you have to square. That means I write out as 20 square, then sine theta. So I already know that sine theta means sine 1.2. Okay, so the triangle also settled. You have 2 triangle, so you just need to multiply with 2. Okay, then let's have a look for this one, the semicircle. So to find out the area of the semicircle, basically I need the radius of this small circle here. So how can I find out the radius? Okay, so maybe this is a bit extra for us, extra step for us to calculate it before we can calculate the area. Right, so I want to know the circle, the radius of the circle. Let's say this is the center of the circle. Okay, then by right, I can divide into 2 triangle, and then I will have 0.6 for a small angle here, and it should be a right angle triangle. Okay, and my aim is to find out this length. Okay, so I label it as R. Alright, so to find the R, you can use the trigonometry ratio in this right angle triangle to find out the R. Okay, so after I found the R, only I can get the area of the semicircle, and after that only I can total up all the area together. Okay, so this is basically what we need to do. Right, so I will start our solution here, yeah. Okay, so I will let R equals to the radius of semicircle BCD and also DF because they should be the same, right? Okay, these 2 semicircles should be the same. Alright, so I'm using the ratio, okay, of a trigo from this right angle triangle here. Okay, looking at the diagram, okay, I'm having the theta the angle is 0.6. So what I want to use is I will use sine 0.6, and I know that it is equals to opposite, which is the r, divided by the hypotenuse, which is the 20. I hope they can see. So 0.6 opposite is the r. So the hypotenuse is 20. So from here, very easily you can get r equals to 20 sine 0.6. Okay, so once you know the radius here, then it will be very easy for us to calculate the area of all the shapes that we have here. Okay, all right, so this is one important value. Okay, all right, so now let's calculate the total area. For total area, I need the sector. So I'll put it as A, area of sector, plus 2 area of triangle, plus 2 area of semicircle. Okay, so let's start with the area of sector first. So like what I told you just now, it should be half r square sine, sorry, not sector means this one. So it should be half r square, then you take 2 pi, which is 360 degree, minus the 2 theta, which is 2.4. So this is basically the area of sector, then plus 2 times area of triangle. So 2 times area of triangle will be half r square, a times b lah, so which is 20 times 20. I also write as 20 square. Then sine c, which is sine 1.2. Okay, then lastly we should try to find out the area of the semicircle. There are 2 area of semicircle, right? You can actually directly find out the area of one complete circle, because these are 2 semicircle. So the area of one complete circle we pi r square. So pi, but now your r here should be 20 sine 0.6, and then you square it. Okay, so basically these are the 3 important area. So I combine these 2 semicircle become 1 pi r square. Alright, and after that I'm having 2 triangle, which is the center one with sine 1.2, and after that the area of this big sector, which is the first one here. Okay, then you need to use calculator a little bit to help you to simplify your answer. When you press the calculator, if you didn't do any careless mistake, by right you have something like this, 1550.095135. But since the question asking for 3 significant figure as a final answer, right? So you should correct it into 1550, which is 3 significant figure. Okay, so please make sure that you try to figure out how to press the calculator and get this particular value here. And a small reminder for you, when you are trying to press the calculator, right, please set your calculator in the radian mode, because all the angle that we are using here basically is in radian. So when you are trying to calculate the value like sine 0.6, sine 1.2, you have to make it sure that it is in radian form. Then only you can get the correct answer. Alright, so this is how we get the answer for part A. Right, so this is the area, yeah? Okay, so let's proceed to part number 2, part B. Okay, so what they want to in part B. So part B, they said, given instead that the area of each semicircle is 50 pi, so find the exact parameter of the metal plate. Okay, so highlight the keyword area, semicircle 50, and also highlight the keyword exact parameter. So the keyword exact tells you that your final answer should be in a sub form, pi form, or a fraction. It shouldn't be a long decimal number, right? Okay, so area of semicircle is 50 pi. This is the information for us to start with. Then find the exact perimeter of the metal plate. Okay, so let's have a look and see what can we get from the area of semicircle when it is equals to 50 pi first, right? Okay, so let us go back to the diagram so that it's easier for us to refer. Okay, so now I erase all the things here now for part B. For part B, they tell us that the area of semicircle is 50. So they are talking about each semicircle or both of them. So they say each semicircle. That means one semicircle, the area is 50 pi. Okay, so let's have a look for one semicircle here, yeah? So what is the formula for one semicircle here? And now please take note that the theta is no longer 1.2. Okay, so the theta is no longer 1.2, yeah? Therefore, I have to use back this diagram. The value of theta is a theta. Okay, so basically this is the information for us to find out the data first. So area semicircle is equals to 50 pi. Okay, all right. So how can we find out the area of the semicircle? So basically it is half. Okay, so half pi r square, right? So half pi, and like what I told you just now, my r square, I have to refer back to this one. But the difference is I cannot substitute the theta as 0.6 anymore. According to the diagram, I should substitute my theta, my angle as theta divided by 2. Okay, so if I put it inside the formula here, I will be having half pi r squared. So my r will be equals to 20 because the hypotenuse is still the same, which is a 20, and then sine theta over 2. It is no longer 0.6, yeah? Right, then equals to 50 pi. Sorry, I forget about the square here, right? Because it should be pi r squared. And then one semicircle, so it should be half pi r squared. Pi r squared is the whole circle. So semicircle means half, okay? Right, then after that, I should try to simplify all the details here so that I can get the data. Right, so now let us try out. Half is still a half, pi is still a pi. 20, you have to square it, become 400. And then you are having sine square theta over 2 equals to 50 theta. And from here, you can see that there are a few things that you can simplify them. Pi and pi can be simplified. So 2 and 400, this one become 200 here. Okay, so if you simplify equation, so by right, you're able to see that your sine square theta over 2 should be equals to 1 over 4. So what happened to your sine theta over 2? So your sine theta over 2 will be plus minus 1 over 2. Okay, and after that, how to get the value for theta over 2? So I'll be taking sine inverse half. I'll take the positive half, but not the negative half. It is because I know that from the diagram, you can see very clearly that this angle is an acute angle. It's an acute angle. So it should be in the first quadrant. So we should only consider the positive value. Right, so I want to get the value for sine inverse pi over 2. So sine inverse pi over 2, you should get a 30 degree. 30 degree means pi over 6. And multiply the 2 over, you'll be having 60 degree, which is pi over 3. Okay, so we get one important information where your pi should be equals to 60 degree, which is pi over 3. Okay, all right. So once you find out the theta is pi over 3, let us investigate about the diagram one more time. If let's say this is a 60 degree, okay, and both side is the same, that means all the angle should be the same, which is 60 and 60 degree. So all the three angle here is 60, and you should know that it is an equilateral triangle. Okay, so when you're having equilateral triangle, you also know that, okay, the total length for this one is 20, because they should have the equal length, right, for each side. And if let's say you know that this is a 20, then by right you should also know that the radius for the small circle here should be a 10 cm. Okay, right. So now I already know the radius, and we can slowly figure out the perimeter. All right, so let's have a look for the perimeter now. Okay, so to get the perimeter, right? So we need to figure out that, okay, this one is a 10. Okay, so to get the perimeter, I want to get this length and also this length. So this is basically the circumference of a circle. So the circumference of a circle is 2 pi r. So 2 pi, and then what is the r here? So you know that for this particular circle, the radius is 10. Okay, so that means you successfully get the semicircle. Sorry, the circumference of these two semicircles. Alright, then plus, what else do I need to include in? So I need to include this length, the arc length of the sector. So what's the arc length of the sector here? It will be r theta. What is the r? R is 20. How about the theta? So theta is still the same. You take 2 pi minus pi over 6. Pi over 3 and pi over 3. Okay, so minus pi over 3 and also another pi over 3. So this is r, then theta. Okay, all right. And after that, when you try to simplify them, you'll be having 20 pi plus 80 over 3 pi. Then simplify further, you need to keep your answer in this form where it is equals to 140 over 3 pi. You have to keep your answer in the exact form. Therefore, your answer should be in the pi form. It shouldn't be a long decimal number or a 3 significant figure answer. Alright, yeah, so this is how we solve the question 7. Alright, so we are at question number 8 now. They want us to express this particular expression into this form. It is a completed square form, a completing square form, where a and b are constant to be found. Okay, so let's start with this one. When you want to completing square, you have to make sure that the coefficient of x squared is always a 1. Therefore, what we usually do is that we will factorize out the 3 from x squared, and then also from the negative 12x, so by right you should have negative 4. Okay, then we have to start the completing square process where you need to plus something square and minus something square. So what's the something here? The something here, the value of the something here basically is the b. Okay, negative 4 divided by 2. So you should have a negative 2 here. Negative 2 square and also minus negative 2 square. The last term constant will not be affected, so I just keep it as a 14. Alright. Okay, after that, what you need to do is that you have to combine the first 3 terms, become one big bracket with a square outside. So I'm having x minus 2 square. Then for the term at the back here, you just expand it. So you're having negative 4. Negative 2 square is a 4, right? Okay, then plus 14. Okay, so next step, you have to multiply the 3 into the both term inside the bracket. So you're having 3, then x minus 2 square minus 12, then plus 14. And eventually, what do you get here is 3, and then x minus 2 square plus 2. Okay, so this is how we're completing the square for this particular expression. Then after that, they are telling us that it is a function fx and defined for x greater equals to k, where k is a constant. Find the least value of k which the function f inverse exists. So to make sure that the inverse function exists, you have to make sure our function is a one-to-one function. So f must be one-to-one function, then only your inverse function exists. So how can I make sure that f is a one-to-one function? So according to the completing square form here, right, I know that this quadratic curve is having a minimum point 2 and also 2. When you're having a minimum point 2 and also 2, so your graph will look something like this. 2 and then 2 here. Let's say this is a 2. So you try to sketch the diagram, it will look something like this. Okay, and very obvious, it is not a one-to-one function because if you draw any horizontal line, okay, along the graph or across the graph, basically you can see 2 intersection points. Okay, so that's why this is not a one-to-one function. If let's say you want to interpret the whole graph, right, so we have to actually cut our graph into half. So what should we do is like, usually what we do is we'll cut it from the minimum point. So they have 2 parts of the graph. One part is this one. You can consider this one where it is x smaller equals to 2, or this part where x is greater than 2 or greater equals to 2. So for this question, they're asking for x greater equals to k, right? So to make sure that my graph become one-to-one function, I have to erase this particular part of the graph, or I only consider the part of the graph when x is greater equals to 2. So you compare it with the domain defined here. So from here, you know that your k should be equals to 2. Okay, they're asking for the least value of k, so that means it must be a 2. Because if you try to consider a 1, if let's say you consider the 1 here, your graph is going up. So when you draw any line from this part to this part, it is not a one-to-one function anymore. Okay, then some students say, can I consider a 3? If you want to consider the 3, it is still a one-to-one function, but this is not the smallest value for the k, okay, where the function f inverse exists. Right, so the smallest value, it should be always on the stationary point, which is x equals to 2. Right? Okay, so let's proceed further for part number C. For part number C, for the rest of this question, you should assume that k have the value in part B. So k is equals to 2, right? Find an expression for f inverse x. Right, so every time when we want to find out the inverse function for any quadratic expression or quadratic function, we need to start from the completed square form, this one. Okay, so I'll let y equals to the completed square form 3x minus 2 square plus 2. Okay, this is y in terms of x, right? Y equals to something something x. To find the inverse function, I will want to express it become x equals to something something y. Alright, so I will try to move all the number to the other side. I'm having y minus 2 equals to 3 and then x minus 2 square. Then after that, I bring the 3 over. That will be having y minus 2 divided by 3. Okay, then x minus 2. You have to take the square root where it will become plus minus square root y minus 2 and divided by 3. Then x is equals to 2 plus minus this one. Okay, so this is what I mean by changing y equals to something something x become x equals to something something y. Okay, all right. So which one is the correct inverse function? Because if you have a look for this one, they are having two answers here. One answer is 2 plus square root something, and another one is 2 minus square root something. Okay, but you can only choose one function as the correct inverse function. It shouldn't be 2, because one-to-one function means that you only have one answer, right? So your solution here got option for you, two answer here. So which is the correct answer basically? Right, so to decide the correct answer from here, you need to know that we are looking for the range of function inverse, the range of the inverse function. So to get the range of the inverse function, you need to know also that the range of the inverse function basically is the same as the domain of the function. So let's go back to our domain just now. Our domain is x greater equals to 2. Right, so k is 2, so x greater equals to 2. So you have to ask yourself, which function will give you a value that's greater or equals to 2? 2 plus something will give you greater equals to 2, or 2 minus something. So definitely this is more than 2. This is less than 2, right? Therefore, your correct final answer for the inverse function, there's only one, which is 2 plus square root x minus 2 divided by 3. Okay, so this is basically how we decide it. All right. Okay, then let's continue to the next part. Okay, for part D. Now they said hence or otherwise solve the equation composite function f of x equals to 29. Right, so let us recall again, yeah. What is our function fx? Okay, so the function fx is basically, you can put it into the completed square form if you want. Okay, or you can just keep it as the original function, where it should be 3x squared minus 12x plus 14, right? Okay, so this is a completed square form. This is the original form. When they want to find out the inverse, sorry, not the inverse function, the composite function f of x equals to 29, For me personally, I feel that if I substitute, if I'm using the computer square form, will be much more easier than this one. Of course, anyone also can, alright? You can try to use the long original equation also can, but when you expand it, just expand it very carefully. Don't do careless mistake. Okay, so for me, I'm trying to use this. I want to substitute the function fx. That means I want to substitute 3x minus 2 square plus 2 into the function f. So substitute this one into this equation. So what do I have is I copy the 3. The x, I will need to replace it with this one. So when I replace it with this one, I will be having 3x minus 2 square plus 2. This is my x. Okay, then minus 2 square. So I'm having a minus 2 and then close bracket square, then plus 2. And it is equals to 29. So the the blue color here basically is my function fx. I'm putting fx into the fx again. So I'm putting the fx into the x in that particular function. All right. Then I try to simplify it. So plus 2 minus 2, very obvious you get a 0, right? So that's why I mentioned that earlier that this is easier for us to simplify. So you're having 27. So 29 minus 2, you get 27. Then you're having 9 here. Then x minus 2 power 4 equals to 9. Bring the 3 over, right? Then x minus 2 power 4, you'll get plus minus 1. You'll get a 1. 9 divided by 9, you get a 1. Then I want to take the fourth root. So the fourth root, you have to consider the plus and minus sign. You get a 1 here, plus minus 1. So you're having x equals to 2 plus 1. Another one is x equals to 2 minus 1. So eventually, what do you get for the value of the x? So value for x will be 3 and also 1. Okay, and for your information, for this question, right, I will ignore the answer of x equals to 1. I will only consider the answer which is x equals to 3. So why? What is the reason I only consider one answer here? Okay, so the reason is because of the composite function. Yeah, for the composite function f composite f, you need to refer to the domain of the function f because this is where you start the composite function. So the very first function that we apply here is the f. So you have to consider the domain of the f. So what's the domain of f just now again? So the domain of the function is basically x greater equals to 2, right? So we only accept the answer x greater equals to 2, which is 3. The 1 here is less than 2. So we don't accept this answer and we only accept x equals to 3. Okay, so this is how we solve question number 8. Right, so we are now at question number 9. They give us a diagram and they tell us that, oh, this diagram shows the equation of 2 cubic equation. They want us to find the x coordinate of the point of intersection. Okay, so every time we want to find the point of intersection, we just need to solve the equation simultaneously. Alright, so I will let equation number 1, which is x power 3 minus 3x plus 3, and it is equals to 2x power 3 minus 4x squared, then plus 3. Okay, so if I try to simplify my equation here, x power 3 bring over become x power 3, then I'm having negative 4x squared plus 3x. 3 and 3 cancel out, become 0. So you're having this equation now. And after that, I realized that I can factorize out the x, right? So I'm having x squared minus 4x plus 3. Then further simplify it or further factorize it. I'll be having negative 1 and also negative 3. So eventually you're having 3 values for the x where x equals to 0, x equals to 1, and also x equals to 3. So this is basically the 3 x coordinates for the intersection point between the curve. Okay, so if you want, you can actually double check, yeah? So x equals to 0 means this particular point, which is true, because you can see that they intersect at x equals to 0. X equals to 1 basically means this one, right? Okay, because they intersect at this point. And after that, the last part here, by right, this is a 3. Okay, so you can double check your answer from the diagram or use the diagram to help a little bit and try to check again whether your answer is correct or not. Okay, then after that, let's continue to part B. For part B, they want us to find the area of the shaded region. Highlight the keyword area. When you want to find the area under the graph or between the two curves, right, we basically need to apply integration. So I will go back to our equation again, our diagram again. Right, so to find out the area, this is part B. I will write the solution here. Right, so basically to find the area, you need integration. Okay, so since this particular diagram is covered by two curves, so I know that I need to include the limit from where the area starts. So this is the limit, the lower limit where the area starts, right? This is the area that they want you to find. Okay, so the lower limit is 1. Where the area ends? So the area ends at the line x equals to 3. So the limit will be 1 to 3. Okay, then you should take the upper curve. What's the upper curve here? The curve on top. So as the curve on top here, it will be x power 3 negative 3x plus 3. Then minus the curve at the bottom. So 2x power 3 minus 4x squared plus 3. Okay, so if I take this curve minus this curve, and I try to simplify them, minus this whole thing. Okay, then you need to start the integration. So some students say that if I use the sequence wrongly, the equation wrongly, how? If you use the bottom one minus the top one, if you use the bottom one minus the top one, right, later after the integration, you get a negative value for the area. You just directly change it, become positive. That's it, right? Okay, so for my practice, I prefer to simplify the whole equation first before I start integrating them. So if I simplify them, I'll be having negative x power 3 plus 4x squared minus 3x. Then only I start the integration so that your integration doesn't look so complicated. Right, so x power 4, power plus 1 become 4 divided by the new power 4. Copy the constant 4, x power 2, power plus 1 become a 3 divided by the new power 3. Then copy the constant 3, power 1 plus 1 become a 2 divided by the new power 2. Then substitute the value 3 and also 1. Okay, so if you try to substitute the value here, so substitute 3. 3 power 4, you have 81 over 4 with a negative sign. Okay, so 3 power 3 is a 27 divided by 3, you get a 9. So 9 times 4, you get 36. 3 squared is a 9. 9 times 3 is a 27. Okay, then after that, you need to substitute the 1 now. Substitute 1, you have be having negative 1 over 4 plus 4 over 3 and also minus 3 over 2. Okay, then just try to simplify the answer here. And by right, if you don't do any careless mistake, it should be equals to 8 over 3. Right, yeah, so these two questions basically is not too tough. Right, and this is how we solve this question number 9. Okay, so we are now at question number 10. So we are given point A and B. We're having these coordinates. Then there's a circle with radius 10. Pass through the points A and B. Okay, right, so for this question, it is about a circle. Right, then you're having 2 points on the circumference of the circle. Show that the center of the circle lies on the line y equals to half x minus 4. Okay, so they want us to show that the center of the circle lies on this line. Okay, so before we can start answering this question, maybe you can analyze a little bit where, let's say I'm having a circle. Okay, and let's say this is a center and I label it as origin or O, but it is not origin. Okay, so you're having the coordinate xy. And after that, I know that the point A, 4, 3, and also point B. Point A and point B can be anywhere as long as they lies on the circle. So maybe B is 8 and negative 5. So this is generally what we have. And we know that the radius means O to A is a 10. Then at the same time, O to B is also a 10. Okay, the radius. Alright, so if we have a look for this info or this information given, right? How can I prove that the circle lies on this line. Okay, so maybe we try to think about, is there any special properties that we have when you're having 2 points lying on a circle? So actually we have one where if let's say I'm having 2 points lying on a circle, right? Then the chord, okay, the chord for the point AB is basically perpendicular, okay, with the line going to connect with the O. So that means for O, the perpendicular bisector, if you draw a line perpendicular or maybe 90-degree towards the A and B, right? It is generally the perpendicular bisector of the point A and also the B. So this is a property that maybe we learned in secondary school or maybe the middle school. So I have to recall a little bit about these properties here. Okay, so if I know that the point O lies on this perpendicular line, then I can try to find out this equation, the perpendicular equation here. Then from there I can know that whether O is lying on this particular equation or not. Right, the line shown in the question. Okay, so let us start. If I want to find out the red color equation, the red color equation here, you need the passing point, but you don't know what's the passing point for now. O, you don't know the coordinate. But I know that this line will pass through the midpoint of A and B because it is the perpendicular bisector for A and B. Okay, so I know that the midpoint for A and B will be the passing point of the red color line. And after that, I want to find the gradient of the line. So maybe I can start with the passing point first. Okay, all right, so to find the passing point, generally I know that the midpoint of AB is the passing point of the perpendicular bisector. So find out the midpoint of AB first. You are taking the x coordinate plus x coordinate divided by 2. Then y coordinate plus y coordinate divided by 2. So by right, your midpoint of AB is actually 6 and -1. And this is the passing point for the red color line, and I will use it to form the equation of the perpendicular bisector later. Okay, then the second information I need is the gradient of the line. And I know that this red color line is perpendicular to the AB line, right? So that means I can use another property that we learned earlier. We find out the gradient of AB first. It is y1 minus y2 divided by x1 minus x2. Okay, then we get a -2. And since we know that the gradient of the perpendicular bisector multiply with the gradient of AB, because they are 90-degree each other, right? So when you multiply the two gradient together, it will be equals to -1. So from here, I know that the gradient of the perpendicular line will be -1 divided by -2. So the gradient of the perpendicular line is equals to 1/2. So these are the two important information that I need to form the red color line, which is the perpendicular bisector of AB. And we also know that the center O will be lies on this red color line. So how can we form the equation for the red color line? Okay, so you can write it out in this way: equation of perpendicular bisector AB. Okay, so to form any linear equation, you need y minus y1. So the passing point that I'm using is this one. So you'll be having y minus -1 equals to mx plus c. So your m is half. X, you copy the x, or you can use half mx minus x1. So the x1 coordinate will be the 6. So x minus 6. Then if I try to simplify this particular equation here, okay, move the number on the left to the right hand side and then simplify them. And the equation that I get, the perpendicular bisector equation that I get is this one. So double check it with our question here. Okay, so it is clearly shown that the line, the point O, lies on this perpendicular bisector of AB. Okay, yeah, so this is how we get the answer for first part. All right, so let us have a look for the second part now, for part B. Yeah. Okay, so for part B. Okay, so for part B, I just try to bring over the diagram here so that you can still see everything clearly. Then now they want you to find two possible equations of the circle. There are two possible equations. Okay, so to form the circle equation, basically we need the center and also the radius. For the radius, no problem because I have the radius 10 already. But now the problem is I don't know the center. So how can I get the center O? Alright, the coordinate for the center O. So originally it should be X and Y. Alright, but just now we already proved that the line O, the point O, lies on this particular line, right? So Y equals to half X minus 4. So that means the Y coordinate for the O will be half X minus 4. So X is the X, then the Y coordinate is half X minus 4 because it lies on that particular, the perpendicular bisector line of AB, right? Okay, so I know that now my coordinate of center is this one, and I know that the radius is 10. So I want to use the length or the distance between point O and point A and let it equals to 10 because that is the radius. So from here, maybe I can solve for the equation and get the value for the X. I need to know what's the value for X because I need to have the coordinate of the center. All right. Yeah, so you know that let center of the circle is the O is having this coordinate where X and also half X minus 4. Okay, then I know that OA is equals to 10 because OA is the radius. How to calculate the distance of OA? So we are taking X minus X1 square. So X minus 4 square plus Y minus Y1 square. So I'm having half X minus 4, then minus the Y1 which is a 3 and then square it. And basically we have a 10 here. Okay, then what am I going to do now is I try to further simplify it. I want to get rid of the square root. So to get rid of the square root, I will bring it over, become the square. So I'm having 10 square, which is 100. Okay, so to get the value for X, I try to expand them. So 7 times half times 2. So you're having a negative 7x plus 49 equals to 100. Okay, then we try to simplify everything here. I'm having 5 over 4x squared. Then I will be having negative 15x. Then minus 35 equals to 0. So you try to group all the number to one side and then you simplify and get this equation. Then I want to get rid of the denominator 4. So I multiply the whole equation with a 4. So I'm having 5x squared minus 60x minus 140 equals to 0. And then I realize that I can further simplify my equation. Okay, so from here I think it's quite clear that I'm getting a quadratic equation in terms of x. So to get the value for x, I need to factorize it. Okay, so to get the negative 12, I should have 14 and 2 minus 14 and then plus 2. So from here you get two values for the x. So x equals to 14 and also x equals to negative 2. So when you're getting these two answers, right, basically it also fulfill what the question wants us to find because they want us to find out the two possible equations. Since you are having two different values for the x, therefore you're having two different center, right? And therefore you can use them to find out the equation of the circle later. Okay, so now I try to get the y coordinate first. So when x equals to 14, what happened to the y coordinate? It is half x minus 4. So half x minus 4. So 7 minus 4, you get a 3. So your first center is 14 and 3, the coordinate, all right? For the second x, you are getting negative 2. So what is the value of the y when you substitute negative 2 into your equation? So negative 2 minus 4. Okay, so you should be having -5 here. That means you're having the second center, which is -2 and also -5. All right, then we already know that the radius is a 10 unit, right? So the first equation of the circle. So our first equation, I'm using this one, 14, 3. Okay, the general equation for the circle is x minus the center, x coordinate for the center, and then you square it. Then y minus the coordinate, y coordinate of the center, and you square it, equals to the radius square. Alright, so this will be the first equation of the circle using the center 14, 3. Okay, then how about the second equation? So the second equation, I'm using -2 and also -5 lah. Okay, then again, the equation will be x minus the x coordinate, then you square it, y minus the y coordinate, and you square it, equals to radius squared. Then I can further simplify my bracket here, so I will be having x plus 2 square, then y plus y square, equals to 10 square. So this will be my second equation of the center by using the second equation of the circle by using the center -2 and also the -5. Right, so this is how we solve question. Right, so the last question for this paper, we are having the equation of a curve, which is this one. K is a constant, so find out dy dx and also d square y dx square. Right, so to find the differentiation, basically we have to do it term by term here. Okay, so for the first term, k is a constant, right? So you just copy the constant, pull the power half in front, so you're having a half, copy the x, power -1 become -half. Okay, then -4 is a constant, you try to copy it, power 2, you put it in front, so you multiply a 2, then copy the x, power -1, 2 minus 1 become a 1. Differentiate any constant term, you will get a 0. Okay, then we try to simplify our answer here. So by right, you'll be having k over 2, then x power -half, then minus 8x. And this is my dy dx. Okay, then if I want to get the d square y dx square, we have to continue from dy dx here. Okay, so what's the d square y dx, d square y dx square here? So again, k over 2 is a constant, you just copy for the first term. Then you bring the power half in front, so it will become -half. Copy the x, power -1. So -half minus 1 become -3 over 2. Okay, same thing happen here. Differentiate -8x, you will be having -8 because the x power 1 minus 1 becomes 0. So you left only the 8. Right. Then again, simplify the term here, you'll be having -k over 4. Then x power -3 over 2 and -8. So this will be the second derivative of the equation y that we have here in this question. Alright, okay, so let's continue to part B. Part B is at the bottom, okay. So for part B, they said it is given that k equals to 2. So please take note that when you give you the value k equals to 2, it only belongs to this part B. Right, so that means if later got part C or whatsoever, right, you cannot use back this value unless they state it again. Okay, so for k equals to 2, it is given under the part B, therefore it is only true for the part B. So take note on this. Okay, so now they said that we are having the k equals to 2. They want us to find the coordinate of the stationary point and determine the measure. Right, so to decide the stationary point, we always need to solve the equation when dy dx equals to 0. Because at the stationary point, okay, the equation or the gradient of the tangent is always horizontal. The gradient is always a 0 because the line of the tangent is always horizontal. Right. Okay, after that we need to decide whether is it maximum or minimum. So let's have a look for our dy dx here. So my dy dx is this one, which is k over 2 x power negative half minus 8x. Alright, so I copy down my answer first. So I'm having dy dx equals to negative, half k, or k over 2 lah, x power negative half minus 8x. And now they say that at stationary point, we know that dy dx equals 0. So I put it as 0 here. Then I'm having k over 2 square root x minus 8x. So to solve for the x, I need to bring the 8x over. Then I'm having k divided by 2 square root x. And now I try to move the square root x go up to the left hand side. So square root x go up to the left hand side. You're having x power 1 multiply with x power half. So you have to add the power together, become 3 over 2. Okay, then I'm having k divided by 8. You bring it down, becomes 16. 8 times 2 is 16. Okay, and since at the beginning of the question, they did tell us that k is equals to 2, right? So I can substitute a 2 here. So 2 over 16, you'll be having 1 over 8. And how can I get the value for the x? So to get the value of for x, on this power, you're having power 3, then divided by 2, right? So for the denominator, okay, it is a 2. That means you're having a square root. If you want to bring it over, if you want to bring it over, maybe I should explain it in this way. So if I want to make the power 3 over 2 disappear, what I need to do is like, I need to put a power of 2 over 3, so that when you want to simplify the power with power, right? So cancel off, you get x power 1. So if you are doing this, then you have to do the same thing on the right hand side as well, where you have to take 1 over 8, then power 2 over 3. That means you have to take the cube root first, then only you square it, right? So from here, you can get your value of x, which is equals to cube root of 1 is a 1, cube root of the 8 will be a 2. So 1 over 2, when you square it, you'll be having 1 over 4. A moment, yeah. So we are having 1 over 4. Okay, so you get the x coordinate equals to 1 over 4. Then now, of course, you need to continue to find the coordinate of y, right? Because they're asking for the coordinate of the stationary point. Okay, so what we have here is, I want to find the y. Okay, so to find the y, maybe I can just show you here. Okay, so to find the y, I have to substitute into the equation. The original equation is k x power half, right? So the k is a 2. X that we get is a 1 over 4, then power half, then minus 4, x squared. So x is 1 over 4 again, then power 2, plus 2. Okay, then we try to simplify all our answer here. 1 minus 4 over 16, then plus 2. So your y coordinate basically is 11 over 4. Right, so from here, I know that my stationary point coordinate is 1 over 4 and also 11 over 4. But we haven't completed this question yet because they are asking also the nature of the point. So to decide the nature of the stationary point, you need to substitute the value into the d squared y dx squared. Okay, so what is my d squared y dx squared? So again, it is negative k over 4, right? So I write negative. K is a 2 in this question. So negative k over 4. Then x power 3 over 2 at the denominator. So x is 1 over 4 power 3 over 2. Because the negative power bring down become positive, right? So it becomes the positive power in the denominator. Then minus the 8. We try to simplify the value from here, and I'm having negative 1 over 2. So for this particular term, 1 over 4 power 3 over 2, you need to take the square root first. which is 1 over 2, then only you cube it. So you'll be having 1 over 8. Okay, then minus 8, and if you try to simplify from here, you'll get negative 12. So when your d squared y dx squared is having a negative 12, a negative value, it is a value that is smaller than 0. So when you're having the value smaller than 0, the conclusion is you should have this stationary point as a maximum point. Okay, so from here we successfully get the stationary point lah, where we know that 1 over 4 y coordinate 11 over 4 is a maximum point. Okay, so this is how we solve the part B here. And let's continue to the last part, part C. Okay, so for part C, now they are telling us that points A and B on the curve have x coordinate of 0.25 and 1 respectively. For a different value of k, the tangents to the curve at the point A and B meet at the point with the x coordinate 0.6. So they are talking about the tangents to the curve at these 2 points. So the intersection for the tangents will be at x coordinate 0.6. So they want us to find the value of k. So for this question, the keyword is tangent to the curve at these 2 points. Alright, so to find the intersection point of the tangent, you need to form the tangent equation first, then only you can solve them simultaneously. Okay, huh? Alright, so first of all, I want to form the tangent, the equation of tangent at the point A. So at point A, okay, your x is equals to 0.25 or 1 over 4. Okay, first thing I want to know what's my y coordinate first. So my y coordinate will be, I have to use back the k in our equation here, because just now when they say k equals to 2, right, it is only referring to part B. So in this part C, you will see that they didn't mention anything about the value of k, but instead we need to find the k, right? Therefore, you have to use back the original equation where you're having k and then x power half. So the x here is 0.25 power half, then minus 4x squared. So minus 4, your x is 0.25 and you square it, then plus 2. Okay, then when you try to simplify your coordinate of y, you should have half k minus 1 over 4 plus 2, and eventually you're having y equals to half k plus 7 over 4. This is your coordinate of point A. So x is 1 over 4, y is this whole thing. Okay? Then how can I get the gradient of tangent? So to get the gradient of tangent, I find out dy dx. Again, you have to use back the original equation of dy dx, where k cannot be a 2. Right? So the original dy dx is k, keep it as a k over 2. Then you are having x power negative half. So my x here is 0.25 power negative half minus 8x. So minus 8 multiplied with 0.25. So if you try to simplify this particular term, you'll be having a k. Then multiply 8 with 0.25, you have a 2. So it will become k minus 2. Okay, so you need to know that this is the gradient of tangent at point A. This is the passing point. Okay, point A. Passing point means include the x and also the y. Okay, so your y coordinate is this particular value. And now I want to use these two information, the passing point and also the gradient of the line, to form equation of tangent at point A. Okay, so how can I find it out? So the general equation is, the general formula is y minus y1. So you take y minus your whole coordinate of y is this one. So minus half k plus 7 over 4 equals to m. So m is k minus 2, x minus x1. So you take the x minus the x coordinate here, which is 1 over 4. Okay, then later if I want to solve the equation simultaneously, right, it will be easier if I just let my equation y equals to this whole thing. I bring the y coordinate to the other side. So I will get half k plus 7 over 4 here. Okay, so this is my first equation. Alright, so my first equation of tangent at point A lah. Alright, then now I want to continue and get the equation of tangent at point B. Okay, so for point B, I will write up here. Okay, so for point B, I know that x is equals to 1. So again, I try to find the y coordinate first. So if I want to substitute into y coordinate, I'm having k x power half minus 4x squared, then plus 2. So if you try to simplify the whole equation here, by right, you'll be having k minus 2. Okay, so this is your y coordinate at point B, for the point B. Right. Then the same thing happen, I need to get a value for dy dx. So to get the value for dy dx, use back the original value for dy dx where you have to keep the k. So you're having k over 2 x power negative half, so 1 power negative half minus 8x, so minus 8 times 1. Simplify this term, you'll be having half k minus 8. Alright, and this is basically your gradient of tangent. Then equation of tangent at B. Okay, so again, this is your passing point. Where your y coordinate is k minus 2, x coordinate is a 1. This is the gradient of tangent. So when you're having a passing point and also the gradient, you can form the equation of tangent. So again, y minus y1 equals to m. M is the gradient. Then x minus x1, so minus 1. Then I'm having y equals to half k minus 8 multiplied with x minus 1, then plus k minus 2. Okay, and this is my second equation. Okay, so I'm having these two equations of tangent now. This is the equation of tangent at point A, and this is the equation of tangent at point B. So let's go back to revise our question again. So they said these two tangent, right, meet at a point with x coordinate 0.6. So that means when you solve these two equations simultaneously, right, the answer that you get for the x is 0.6, which is 3 over 5. Okay, so I try to solve equation number 1 and equation number 2. That means I let equation number 1 equals to equation number 2. So how will my equation look like? So you can say 1 and 2 intersect at x equals to 0.6, which is 3 over 5. Okay, right. So equation number 1 is k minus 2, then x minus 1 over 4. So I substitute the x by using 3 over 5 minus 1 over 4. Then plus half k plus 7 over 4. Okay, so this is equation number 1. So I solve it simultaneously, means I let equation number 1 equals to equation number 2. So for equation number 2, we'll be having k over 2 minus 8, then x minus 1. So the x here I substitute by using 3 over 5 minus 1. Okay, then plus k minus 2. So equation number 1 equals to equation number 2, and we know that the value of x is 3 over 5. So I substitute 3 over 5 here. And also this one. Okay, then the next step is we just need to try and expand our equation here very carefully. Okay, so what can we do is like you can just take 3 over 5 minus 1 over 4, then multiply into this bracket, you'll be having 7 over 20k. Okay, so minus 7 over 10 plus half k plus 7 over 4. Simply happen here, simplify all the terms on the right hand side of the equation. So you're having negative 1 over 5k plus 16 over 5, then plus k minus 2. Okay, so to solve for the value of k, we try to move all the k to the left hand side. So when you try to simplify them, you'll be having 1 over 20k. So you spend some time to gather them together and see whether you get this 1 over 20k or not. And all the number, I will move it to the right hand side. Then when I simplify them, I will get 3 over 20. So from here, this is how I get the value of k, which is equals to 3. Alright, yeah, so this is how we get the answer for question number 11, and also this is the end of the video. So thank you very much for watching the video.